Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if that test score you got last year means the exact same thing as a score you might get next year? What if the way you are tested changes? Does your real ability change, or is it just how we're measuring it? Today we're diving into a fascinating area of research that explores something called scoring condition drift. It sounds a bit complicated, but it is all about how our performance might be judged differently, depending on the exact situation or conditions under which we're rated. It's a deep dive into whether a score really means the same thing today as it did yesterday. So imagine a test or an assessment where a human has to score your performance. This could be anything from an essay you write, a presentation you give, a clinical simulation you perform, or even how you behave in a classroom. These kinds of assessments are super important for making decisions about where you go to school, if you get certified in a job, or how well a program is working. But the big question is, do the scores given really mean the same thing every time they're given? This paper proposes a way to study something called scoring condition drift. Think of it as the meaning of your score slowly changing over time, because the way it is measured or the context around it changes. This is the core idea. What if the question you are asked changes? What if the scoring guide, the rubric, is updated? Or maybe the training the people giving the scores receive is different. Even the computer program they use to score, or how important the score is like for a big promotion versus a practice quiz, can change things. The researchers want to understand if these changes cause the relationship between what you actually do and the score you get to shift. They want to know if you get a different score not because you got better or worse, but because the test itself or how it is scored changed. They break this drift down into a few key ideas. First, is it a simple shift where everyone gets slightly higher or lower scores, but the way different parts of your performance are valued stays the same? Or is it a change in how much weight each specific feature of your performance is given? For example, maybe before, grammar errors were penalized a lot, but now the focus is more on the strength of your ideas. They also want to separate changes that happen on the rater's side, like their training or the rubric, from changes on the performer's side, meaning you might change how you perform because you know how you'll be scored. To really get a handle on this, they use a specific example to make things clear. Let's picture a writing assessment at a university. Students write an essay using some sources. The people scoring them use a guide or rubric with 4 parts: claim and argument, organization, how they use evidence like citing sources, and language control. The scores from these parts are combined, usually with some parts being more important than others, to decide which writing class a student should be placed into. Now imagine the program decides to change things. They might change the essay prompt, so students have to use 2 sources instead of 1. They might train raters to pay extra attention to citing sources correctly. The scoring software might be updated to highlight the evidence use rules first, or the decision rule could change, so that a really low score on evidence use means a student automatically goes into a support class, even if their overall score is high. This table shows how these scoring condition components play out across different assessment types. For writing, features are things like claims and organization. For speaking, it might be speed, pauses, and how someone repairs mistakes. For clinical simulations, it is actions, safety checks, and communication. The rubric emphasis, rater preparation, scoring procedure, and decision rule all influence the score. A key drift concern is how evidence use might become more dominant after a revision, or how repairs in speech might be weighted differently depending on the rubric. This highlights that the features we look at, like a pause in speech or a citation in writing, don't automatically mean the same thing score-wise under different conditions. This is a super important distinction. A feature is something you can see or count. It is an observable part of the performance. For example, the number of times you cite a source, or how long a silent pause is when you are speaking. A score, on the other hand, is the judgment made based on those features, using the scoring guide. The feature warrant is the idea that this specific feature is relevant and important for reaching a particular score under the current rules. So, scoring condition drift happens when any of these things change. The kinds of performances people produce might change, or more commonly, the way those features are linked to the scores might change, or even what decisions are made based on those scores could change. And it's important to remember, drift doesn't automatically mean something is worse. A change could be an improvement in how well the assessment measures what it is supposed to, but it might still break the ability to compare scores from before and after the change. This table helps us sort out what might be causing a score change. Is it just that raters got more lenient or stricter overall, which is uniform severity or leniency? Or did the task or prompt itself make students perform differently, leading to different feature distributions? Or is it truly feature warrant drift, where the scoring conditions themselves change how features are weighted. They even talk about performer adaptation, where you might change your behavior because of incentives. For example, if you know hesitations are heavily penalized, you might try to speak faster and with fewer pauses, even if it makes your speech less clear. Now, they get a bit more mathematical to explain this. They use an equation 1, where they try to predict the score, y based on a bunch of factors. There is a baseline part, effects from the condition itself, gamma, effects from the specific rater and the specific performance. And then, crucially, parts that show how the weight of each feature, beta k, might change based on the condition, delta kr times x, kr times r. The big takeaway here is that they're not just looking at the average score, but at how the relationship between specific features and the score changes. If that delta kr part is not zero, then the feature warrant has drifted. They also use a way to measure this change called delta. Or this is essentially comparing how strongly a feature is linked to a score in one condition versus another. If this difference is large, it means that feature's importance has really shifted. They then combine these deltas for all features to get a total measure of drift, symbolized by t. This equation 3, looks at the expected score impact of this drift. Even if a feature weight changes a little, if that feature is very common, it could have a much bigger impact on overall scores. This equation helps them figure out if those weight changes would actually move average scores significantly, given how often those features appear in people's performances. And perhaps most importantly, equation 4 looks at the decision impact. This is the probability that a person would get a different classification or decision based on the old versus the new scoring conditions. So, if a change means someone who would have passed now fails, or someone who would have been placed in an advanced class now goes to a remedial one, that is a big deal. This equation tries to quantify that. Let's look at a real-world example they discuss from speaking assessments. Fluency is a big part of speaking tests. What makes speech sound fluent? Is it just speaking fast, or is it about smooth delivery, fewer hesitations? They discuss a study where the exact same speech samples were listened to by different groups. But each group was given different instructions. One group rated based on global fluency, another focused on pauses, another on speed, and another on repairs like self-corrections. This table shows something really interesting. When raters focused on global fluency, things like pauses and speed were strong predictors of the score, but repairs seemed to have less of an impact. However, when raters were specifically asked to focus on repairs, that feature suddenly became very important and strongly predicted the ratings. This perfectly illustrates feature warrant drift, the same speech, the same features, but the instructions on how to interpret those features completely change their weight in the scoring. Another key insight is that sometimes it's not just about one single feature, but how features work together in a profile. For example, in speaking, someone might pause more if they are also making repairs, or they might speak slower if they are trying to be more precise. They might use different strategies to manage their speech production. A study they mentioned looked at IELTS speaking tests and found that while individual little features, like a single pause or a single repair, didn't strongly predict the overall score band, certain combinations or profiles of these features did. So maybe a lot of short pauses together mean something different than one long pause. This means we might need to look at patterns of features, not just single ones, to understand performance scores, and these patterns themselves could shift with scoring conditions. The researchers also suggest looking at existing research to get a sense of how much drift might be expected. They talk about moderator subgroup correlations. Basically, if you look at many studies on speaking fluency, you can see how the relationship between fluency features and perceived fluency changes depending on things like the type of speaking task, how fluency is defined in the rubric, or how much training the listeners get. For instance, this table shows that the link between fluency and perceived fluency is stronger in controlled monologues compared to more open-ended ones. It is also stronger when the fluency definition is based on a research-backed rubric, rather than just a general researcher definition. This suggests that certain conditions naturally create stronger or weaker feature. Score links. This information can help us predict where drift is more likely to occur. This framework is also designed to be practical for smaller programs, like a local teacher education program with only a few dozen candidates a year. They might not have enough data for super complex statistical models. The paper suggests a straightforward audit process: identify the change, select key anchor performances, some of which should be close to decision cutoff scores. Have them scored under both old and new conditions, code a few important features, and then report any score shifts or classification changes. This is a really practical takeaway. Even with limited data, you can get a good sense of whether a change has a major impact. Knowing that 4 out of 18 near-cut essays changed their placement gives a clear picture of the decision impact. Even if it is not a huge sample, it's about bounding the comparability claim, saying, we know this much about how scores might differ. Finally, the paper emphasizes that how we report findings about drift really matters. It is not enough to just say scores are comparable. If there is evidence of drift, it needs to be reported clearly. This table outlines reporting actions. If there is a small mean shift but stable feature weights and classifications, comparability is likely supported. But if weights change significantly and that affects decisions, then comparability is not supported without a bridge, meaning a way to connect the old scores to the new ones. In such cases, you might need to start a new series of scores. Acknowledging the discontinuity, it's about being transparent about the conditions under which score meaning is valid. So, what does all this mean for us? The core message of this research is that scores from human-graded assessments are not fixed. Their meaning is conditional. The paper, Scoring Condition Drift in Rater, Scored Performance Assessment, a Feature-Warrant Framework, gives us a solid way to investigate when and how this meaning might change. It is not just an academic exercise. It has real implications for fairness and accuracy in education and beyond. The strength of this framework is that it's both scientifically rigorous and practically applicable. It moves beyond simply looking at whether raters agree, and instead digs into how they're arriving at their judgments and how that process might change when the rules of the game are altered. It also does a great job of separating what the performance itself is doing versus how the scoring system, or even the performer reacting to the system, influences the outcome. For me, the most compelling part is the focus on decision impact. In the end, the scores matter because of the decisions they lead to. If a change in scoring conditions means that students are being placed in different classes, or certified for jobs they might not have been before, or vice versa, that is a significant consequence that needs to be understood and communicated. The idea of performing a small program audit is particularly valuable, showing that rigorous investigation of score meaning isn't just for massive testing organizations. However, like all research, there are limitations. The paper itself acknowledges that analyzing existing summarized data can only provide approximate bounds. Real local validation using matched performances is always stronger. Figuring out performer adaptation, whether someone is actually changing their strategy or just having a bad day, can be really tricky to disentangle, especially from just looking at scores and features without observing the actual response process. Looking ahead, this research opens up a lot of avenues. Imagine applying this framework to high-stakes professional certifications or to evaluate large-scale diagnostic tools for learning. Future studies could focus on developing even more refined methods for detecting performer adaptation, or for creating robust bridging studies that allow for meaningful comparisons of scores' significant scoring condition shifts. It is a reminder that assessment is a complex human endeavor. We shouldn't just assume that a score is a pure measure of ability. It is a score that is generated within a specific context, under specific conditions. And when those conditions change, we need to be ready to investigate. That is it for this episode of RUBIN'S Mind Lab. I hope you found this exploration of scoring condition drift as fascinating as I did. If you did, please give this video a thumbs up, leave a comment below with your thoughts, and don't forget to subscribe and hit that notification bell so you don't miss our next dive into the science of the mind. See you next time.